All right, here we go. 1 minute left until day 7 starts. Not really sure I have anything I want to say about day 6 other than I'm a little frustrated that it took me so long just to realize that I needed to change the index to 14. Yeah, otherwise I think it's a decent solution. Usually part 2 is harder. So I wonder if there's some non-optimal solution that people might do for part 1, where 14 makes it a little too hard based on memory or something, or just really slow based on iterating over the loop. I guess if you went over the loop every single time and it was like a big O factorial type algorithm or something, maybe it would be too slow. But since I just kept a moving cursor, it wasn't. I don't know. But maybe there's a slower algorithm where 14 was too long. I'm not sure. Anyways, let's go. Day 7 starting now. Here we go. Oh, interesting. We have to implement our own commands now. All right. So this is our puzzle input with commands. That is crazy. Okay, this is going to be an interesting one. I think I love this already. All right. So they're looking at the file system. So they have CD and ls basically are the two commands that we get to look at. What's going to be interesting here is when they CD, we're actually recursing, so we need to keep track of what directory they're in. It's quite interesting. Okay. So we have to go through and determine what it looks like. Yeah, we have to build our own tree like that. Find the directories that are good candidates for deletion based on size. We know size because ls returns size, right? So, cd slash goes to outermost. Okay, that makes sense, right? Slash is the root. So ls is size and then file name. And dir. So ls is a dir for directory and then files. So it lists directories and files. Okay. Find all directories with a total size of at least 10, 100,000. Okay. So we're going to say 100,000. Yeah. Okay. Then calculate the sum of their sizes. So only these. Wait. Okay, so the example doesn't have any directories that are that big. Wait, I'm confused. At most 10,000. Okay. So that's a max size. I thought that was the min size. All directories with a total size of at most 100,000. So D is too large, basically. So we're only going to look at A and E. Okay, got it. So we really just need to start traversing. So that's what our output looks like. We're going to say for line in, like always, split lines. We need to know, basically we need to know if we're in a command or not. That's going to give us based if line starts with dollar, then we are in command parsing. I actually think it's going to be better if we tokenize this with a while loop instead of a for loop, potentially. Well, will it matter? No, we just have to know what mode we're in, and we're going to do that anyway. Yeah, okay. Well, maybe not. This could be easier. So while line, so we need to get an iterator. So iter of puzzle input dot split lines. We're going to say next of lines. Actually, this is just going to be true, and then we're going to do... No, this is going to get too complicated. It's going to raise a stop iteration error. Oh, there is a default. Okay, so it does take a default. Great. Awesome, that's what I want. So I want while line is next of lines then. False is actually better. Okay. So the first we're going to do is we're going to get command. We're in command mode. So if line dot starts with, we're going to remove this. I actually think we can assume we're in command mode. So let's see. What if we do, is there always 3? No, it's either 1, 2, or 3. So we're gonna, okay, we're gonna split it. I think we can do case dollar. Okay, hopefully this tells us some, I want to use structural pattern matching. I think that'll be really nice. Yeah, a list of whatever. Oh, start object. Great, great. So this will be a list. If it's this and then command, cd, and then dir, then we're going to do if it's case dollar of ls, then print that should be all we get. Is we should just be printing not running this one. Okay, we should just be printing nothing. Okay, so this is not quite working. Okay, so I wonder if the while loop is the issue or the match statement. The while loop is not, because I need it on the test input. Okay, great. So we're seeding, we're LSing. We don't want to print this line anymore because now we're in debug mode. Okay. Great. So we have the CDs and the LSs. That's perfect. That's what we want. Okay. So what we need to do is know our current directory. I think if we just make this a string, we'll be fine, and then we append them, and then, because, yeah, it doesn't really matter how we keep track of this, we just need to know the total size. So, interesting, but we do need to know all the children, so we need to make children nodes, because the size is based on all the children directories. So we do almost need a dictionary of sorts. So current directory is a dictionary, probably. Then we need to go through, let's see. I'm thinking whether or not it's worth making this a class, because then when we add children, we can like auto calculate all of our sizes. That would be cool. I think it's going to help. So what we're going to do is a directory has a parent directory. Can't do that, but you can do self now. Nope. Oh, that's because this isn't a data class. Hold on. Okay, so this is another directory. It can't be that, but it can be a string. And then we have a size. Let's see, it says something about the process can count files more than once. Oh, yeah, so we have to make sure that we don't count a file. Let's see, because it's going over. Oh, we don't have to we don't want to double count a file, basically. Assuming that's what it means. So size is, I mean, it's just a number. And then we want to say files, which is going to be a set. A set of strings. Okay, so then what we're going to do is we're going to have a function called add file, and it's going to have a size and a name, and we're going to say if file name not in files, self.files add name, and size plus equals size. Then what we're going to do is we're going to say if parent, because a parent can be a parent can be another directory. And if so, we're going to call, we're just going to increase its size for it, because we're keeping track of the file. Okay, so that should be it. So basically, yeah, as long as we know which directory we're in, we need to get a directory. We'll just trace that. Okay, so current directory equals directory, like that. Okay, so now what we're going to do is, if we cd into a directory, then we are going to say subdir equals directory parent equals current, and then current equals subdir. And that's really all we need to do. Except if dir equals ... then we are going to say parent equals current.parent. No, we can just set current equals current parent, like that. And else. Okay. Then, now that we have that, ls is going to tell us the results of everything. So I don't really think it matters what the dirs are, because it's just going to cd into one for us. So we don't really care the dir step. So what we're going to do here is interesting. We're going to say, honestly, if we just read these in order, we don't really even need to keep context of what we're in. The input will just kind of do it for us. So in this case, we can just do nothing and let all the CDs do it for us. So if case is dir, something, then we can pass. And then if the case is an int followed by a, well, this is going to be a string. Size followed by file name, then we are going to do current directory.add file size file name. And then when we're done with that whole while loop, we are just going to print current directory size, just because I'm curious, see what that's going to do. Int and string, right? We need to do this. We need to int here, like that. 0. Okay, so adding file never worked. That's good to know. All right, did we ever hit this breakpoint? We did. So current directory is this one. We have a set. We have a file name. We're calling add file. We go in and we add it, and then we, size equals, this needs to be self size. Okay, plus equals parent size. Plus equals actually should be size. That was correct. This one was correct the first time. Okay. Okay, so that's our total size, and is that what they say is the total size? Yes, great. Awesome. So now find all the directories with the size of at most 100 at most. Because interesting. All the directories can include. Let's see. This is interesting because I don't know if a directory can count more than once. It sounds like maybe. I think I'm finally understanding what this is saying. I think this is saying because there's directories and subdirectories. Anyways, we're just going to add all directories to a list. So all directories. And anytime we create a new one, we're going to append it. And then at the very end, what we're going to do is for dir in all directories, if dir.size is less than max size, we are going to print dir.size. We're actually going to sum them all, so sum so far equals 0, and we're going to say sum so far plus equals dir.size, and then we are going to print sum so far. Okay, let's see what that does. We get this number, and that's what it should be. Great. So now let's go ahead and test it with our actual input, which I haven't even gotten yet. And let's run this. We get this number, and let's see if that is correct. No, okay. So I have a feeling this might have to do with recursing multiple directories more than once. Okay, so in our example, what we're doing is we're counting A and okay, so A and let's see, E, which contains I. A contains E, which contains I. So the directory A is this much plus I, and E directory D has too much, so we don't count it. Yeah, because A contains E and we're still adding it, so we're interesting. So it should be correct based on how I believe I've implemented it, where it will double count all those, and our example double counts. Okay, so I mean the input's not terribly long, so we could potentially figure out what's going on here. I wonder if there's like invalid directories here. Do we ever CD into something that doesn't exist? Does it say anything about that? Oh, slash. I didn't handle slash. That's what it is. Let's go here. I need to do slash. So I can actually do this like this. Case dollar CD slash. And then we're also going to do case just like that, except it's going to be a dot dot. That was weird. Okay. And then we don't need this if. This is going to be the dot dot case. We don't need that. We can go that back. And then this is going to be root directory equals directory, and this is going to be root. That's fine. And then we're going to say current equals root. Okay. Pretty sure that was my issue. So let's try this again. Is that the same number as before? Whoops. No, I don't want this. Go away, Microsoft Teams. How did I start you? No. Okay. Oh my goodness. There we go. So 15.33398. So it's not any different even when I handle the slash. It's interesting. I wonder if my input even has a slash other than the first CD. Nope, that's it. That's the only one. So that's why, because I ignore that one. Okay. So it doesn't have to do with the root. Interesting. I'm not really sure what my bug would be. This is going to be fun to debug. Let's just verify the test data still works. Let's see. Yeah, 95437 is correct. All the directories are the total size of at most. What is the sum of the total sizes of those directories? Okay, let's just print. Oh, maybe less than or equal? Same answer. Okay, so we will print dir. Okay, so now it would be helpful to have names. So let's just give these a name. And then we will make this one's name like that. We will rerun this. Okay, so if dir size is less than or equal to max size, dir size is definitely not less than. Oh, its parent is not. But it is. Okay. That's interesting. I mean, so far it looks fine. It's really hard to know. Eight. So I guess I just have to manually check these because I really don't know what else to do. So we have BSL TMJZ. No. So where do we CD into that one? We CD into that one, and we run an ls. And those two together should be, I mean, that looks right. Just shy of 100,000. So I have to be like double counting something. Yeah, I've got to be double counting something. Because it looks... Because the very problem that I would anticipate being a problem is this one where A contains E, and so we're counting this one twice. But that's what we're supposed to do. So this is the worst when the test input works. I'm wondering if my ignoring of these lines is causing a problem. It shouldn't be, because I can't imagine a world where I need to actually care what directories are returned from ls. So for example, yeah, I don't really know, because like they're CDing, they can only CD in dots and slashes. I don't have to do return invalid or anything. There's nothing about invalid directories. So I think I'm just going to define string is going to be return get name if not self parent return self name, otherwise return plus self name. Let's make this an f string. Oh, good old debugging. I'm just trying to make debugging a little bit easier at this point. Yeah, I think that's right. So now if I rerun it, this looks a lot better. So none of the sizes look too big. FFJZ. So where do I CD? Okay, CD and ls, yeah. So it only contains a directory, so that one makes sense. I just noticed that these are the same size. So this one would count, and that one would double count. JBV. So this one's wrong, because I CD into JBVDB. And that one has this one in it, and that one has this one in it, and that has this one in it. I mean, it's only 0, but this could be lingering of another issue. So it's really hard to backtrack this. But JBVD. So where do I CD into that one? Okay. I mean, yeah, it's JBVDB. Oh, good. There's, oh no, so that's the only one. So this one is wrong, because this one has a subdirectory. And that subdirectory has this file. The file is too big, but it is causing a problem. So JBVDB, so let's see if we can find this. Let's remove all these breakpoints. And let's add this one in. And we're going to add a condition here. Dir equals that. And let's see if we get it. Okay, so dir is JBVDB, current directory. Okay, so now what we're going to do is we're going to walk through and see what happens. So I'm adding myself. Next line should be an ls. So I pass, yep, that's fine. And the next line should be a dir. Yep, that's okay. And then I'm going to have another CD. Okay, so current directory should be, yep, my 0. I'm now adding another directory. Now the next line is another ls. So we're right here, and that's going to be a dir. So, and then this is going to be a CD. Okay, so I'm in that one, which I should do. Next line should be an ls. Next line should tell me a file. Okay, so current directory. Add file. This one isn't working for some reason. If name not in self files, which is not, I added. My own size gets incremented. My parent. Oh, I know what I'm not doing. I can't believe I did this. This needs to be recursive. It needs to go all the way down. I'm only going one level deep. I'm kind of frustrated with myself for not thinking about this. So what we're going to do is we're just going to add one more add to size. Just like we did with our debugging string, we're just going to say self size plus equals size, and then we're going to call self.parent.add2size. If self.parent add to size, like that. And then what we're going to do is instead of this, we're going to say self add to size, like that. Now let's rerun. There's our new answer. Shameful. Shameful I wrote that so wrong the first time. Caused me a ton of time. Yeah, all right. So now we need to delete. So this is available size. Okay, so part 2, available size. How much is that? That's okay. And you need unused. Okay, so you need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost. Okay, let's go back to the test example. The outermost directory is 4. This means the size of the island is currently which isn't quite 30,000. The update will still require a directory with the total size of at least to be deleted before it can be run. Yeah, I could always delete root. ENA are too small. Choose the small. Okay, so the smallest thing that will still. Okay, that doesn't seem too bad because we already know everything. So we're just gonna do this all again. Yeah, that should be fine. We should be able to copy this. So we just don't need that max size there. Okay, so we're gonna do it all over again for part 2, and then what we're gonna do is, I don't want this print though. Okay, so we go through all of them, we do the parsing, and then what we do is we go through all the directories, and we're gonna sort. So we're gonna sort sorted all directories where dir key equals lambda directory dot size. Luckily we already have the size key, so it's going to be really easy. That's going to give us the directory's smallest, and we're going to say if dir is okay, so first we need to get total space equals the root directory dot size. So what we need to do is if dir dot size is less than, it's greater than or equal to total space minus, what do we call that? Available size minus total space is going to give our diff no, what we really need is, we're just going sorted, so it doesn't really matter what that is. We need this much. Well, okay. So if we, okay, so we have 70,000 minus okay, so we need to figure out how much we need to free up. Okay, so space to free is going to be available Why is that not auto-completing? Did I remove it? It's weird. I don't know why this basic math is eluding me right now. Okay, So we have available size minus root directory size is current disk space. So current free. What we want to do is we want to know the difference between current free. So amount to free is current free minus, it's actually going to be needed space minus current free. Okay, so what we want to do is see if dir size is greater than or equal to amount to free, and if it is, we are going to print dir and then return, because that's all we need to do. So this one. That looks right. So now, what is the total size of that directory? Now we run it on our official stuff, and we have this number. Let's see if that is right. That's right. There you go. So there's part 2. It's always the simple math that gets me for some reason. Yeah, see you tomorrow.